So for today, just doing a little bit of review and getting your brain warmed up here. This is not 1 over x. Does anybody remember which one it is? There's only two ones we really talked about. 1 over x and one other one. Say it if you know it. There it is, 1 over x squared. That's what this graph was. So instead of doing it the normal way where I'm like, find the horizontals, find the verticals, I'm giving you a graph and then saying, do you remember how to write limits for these? Write the limit on the right end and the limit that's on the right of the vertical asymptote. I put boxes around them. So you can be reminded where they are. So we'll just do that one as a warm-up. I'm going to pause while I give it a shot. Okay. So the right end limit, you just say the limit of the function as x approaches, and again, I like to just kind of like ride along here and say, what is x getting closer and closer to? I guess it's getting closer and closer to 0. No, the y is getting closer and closer to 0, but the x is getting lower and lower. No, it's going way to the right. That's it. It's going way to the right. So you kind of can talk yourself through which way is it going? Okay, so that one was x was going towards infinity and y was going towards not infinity. Y was getting lower and lower, closer and closer to 0. Welcome aboard. All right, so this one, the right side of the vertical asymptote is that one. So how do I do right side of the vertical asymptote? Well, same thing, you just like look at where you're going. If I ride on this thing, it's going up, which is a y thing. So the limit of f of x, the y is approaching, y is getting really tall, so it's going towards infinity. The x is kind of stopped moving because it's getting really, really, really close to 0 from the positives. How many had that exactly right? Okay, awesome. Then I think you get how to write the limits. What if I just said, graph this thing? Here's a nice simple one. 1 over x minus 2. Can you graph that? You'd have to tell me the verticals, the horizontals. If there is any hole, you'd have to say where it was. And then graph it with an xy, like x and y axis and an xy chart. To do this, you have to have at least 2 points that aren't the asymptote, 2 nice clean points, and then you can just draw the lines. All right, I'm gonna pause for a second while you try that one. So Claire, can you tell me how you started? The 1000 trick, because the horizontal asymptotes run like this, and you want to see if way to the right, if it limits out at some number. Okay, good. So you put in 1000, and what did you get? Yeah, because 1 over 1000 is about 0. So y equals 0. All right, next thing, row 3, person 2, Tully, that's you. Can you tell me what you did next?
Found the vertical asymptote.
All right, and what is it at?
2.
Yes, I hope you said x equals 2. All right, that's a big one, because if on the test you just wrote a 2, I couldn't take it, because obviously x and y are different. So x equals 2 is this one. Vertical goes up and down, and it's at 2. And the y equals 0 is this thing is running across this way at 0. Okay, is there a hole? No. A reminder, if there had been like an x plus 5 and an x plus 5 like this, then this would have been in parentheses too. Then this would have canceled. That would have created a hole at -5 comma something. And the -5 is the easy part, because you can just be like, oh, that makes it 0. But you go -5 comma, stick it back in the function to figure out the rest of the hole. That's just a reminder on how those holes would have worked. All right, and now the XY chart, you stick in 0. No, you stick in 2, because that's the asymptote. And that tells you, if I put a 2 right here, I'll get an asymptote, and that tells you to go on either side of that. So I hope you put in 1 and 3. Dominic, what'd you put in? Did you put in 1 and 3?
I did.
All right, what did you get for when you put in 1?
-1.
All right, and when you put in 3?
1.
I agree. So now I'm going to graph those. Over 1, down 1 is right there. No, wait. 1 over 1, down 1 is there. Over 3 and up 1 is there. And so now, hold on. I'll just put a, yeah, you guys can't see that. That's all right. Okay, so I'm going to finish. Sorry, it's my iPad just got messed up a little bit there, but it goes like that and like that. Maybe I should use a different color. Like this blue line goes like that, and it goes like that. Yes?
Shouldn't the vertical asymptote be at 2, not at 0? Oh, wait, never mind.
I think it is at 2. Okay, all right. All right, I know my drawing's messy though, so. Okay, so one last, find the, where exactly the hole in this problem is. So here's f of x equals 2x squared plus 1x minus 3 over 2x that's a factoring one, obviously. And there's more. I got to just figure out the rest of this thing. There it is. On the bottom, change it. It's not 2x anymore. It's x minus 1. That should create a hole. And the question is, where exactly is the hole? You might be able to know where the hole is for the x, and let's say it's like 3 and it's not, but figure out what that is, and you do f of 3 right there. Again, those are not the right answers, but they're kind of like that. So the hard part is, can you factor that top? Because if you can factor the top, then you probably know that something's going to cancel, because the whole point is to make a hole. So I'm pretty sure I set that up so it factors. Can anybody verify they found factors that worked? Yes, there's lots of kids nodding. It does factor. Now, what we're going to do for the rest of the hour is we're going to have a little practice quiz, and then we will see how you would have done out of 4 on that. It's going to be 4 of the hard kind of problems, and I will have you work together with a group to see if you guys can together get a perfect paper on that thing. Then I'll tell you the answers for it. Hopefully you'll have gotten them. If not, you do have an assignment tonight, which is just a normal like worksheet that reviews everything, and there's a key for it. So it should be a pretty cool normal review day. Test is tomorrow. I'm going to pause for a sec while we work out this last. Where is this hole? All right. George, were you able to factor the top? Okay. Start working on that now, please, and we'll go with 2x and x, because that's how it has to start. Dance, can you tell me how you started the factoring? I mean, you must have started with 2x and x, right?
Yeah.
Okay.
And then you need a plus and a minus.
Excellent. I love that you thought about the signs next. You know that's negative, which the only way that can happen is if there's a plus and a minus. You're not sure which spot the plus is in, but there has to be a plus and there has to be a minus. And then give me the last thing that you know, Claire.
The last numbers have to be 3.
Yeah, the only way to multiply to make 3 is a 3 and a 1. Now, did I do it right? Nope. I didn't actually, because I can check, and this comes out to positive. Oh, wait a minute. That is right. I got lucky. I was intending to do it wrong on purpose to show you what to do. If you had multiplied these out and you hadn't gotten 1x, then you just either move the numbers or the signs. If you have the opposite of what you want, you move the signs. All right, so it worked. Now that can cancel, and that creates a hole. Mr. Tivo, can you tell me the x of the hole?
1.
Yeah, because that's what makes the equation 0. It's called the 0, is 1. But now, if I actually plug 1 into this, do you get that the bottom becomes 0 and it'll just die? So you can't put x back into that function, but you can put it back into the remaining function that's left after everything canceled. I'm going to rewrite that over here. Y equals 2x plus 3. That's all that was left. Now, if I want to finish off my hole, I put the 1 in there, and I get y equals 2 plus 3, 5. 1 comma 5. Now I want you to see what that would actually look like on a graph. This right here, y equals 2x plus 3, that's got a y-intercept 3 and a slope of 2. It's really easy to forget when you haven't graphed them like that in a long time. That's just a straight line. Y equals 2x plus 3. It's just a straight line. It's got a y-intercept of 3, slope of 2. But what's different about it is that when you put in 1, you get 5. That's a hole. If I go right here on my graph, over 1 and up to 5, there has to be a hole right there. And so that would be my final answer, is the graph has a hole in it right there at 1 comma 5. All right, so that's a good review, and I'm going to give you a minute. Everybody just look at last night's worksheet. I only assigned the evens. I'd like you to go back, and if you haven't finished that worksheet, do it now. If you have finished that worksheet, just do problem number 1 on it, because I didn't assign number 1, but take a minute, go back and do number 1 on last night's homework. I only assigned the evens, so if you've already done number 1, just do number 3. I just want you to do one more practice problem off of that.